Hello everyone, welcome back to Coding Intuition. Today we are going to solve the question number of closed Iceland on LeetCode. So let us just understand this question first. So in this question we are given a grid like this, and in that grid we are basically only have values of 0 and 1, and we need to identify how many total Icelands are there in this grid. So let us try to understand by an example what are these total number of Icelands. So here in this example, as we can see, we have given a grid, and our one represents water. Wherever we have one inside our grid, it represents water, and wherever we have zero inside a grid, it represents land. So the combination of different zero together forms an island. So we have these many islands and our this grid. So this is an island, this is an island as well, and all of these are islands. But what we need to do here, we need to only identify the closed islands. So what are the closed islands? Basically the islands which are completely covered by the water. So as we can see, it this island is completely covered by the water from all sides. But if we see this island, it is not covered by the water from all sides. It is from these two elements are not covered by the water. So it is an island but not an closed island. So we just need to find out all closed islands. For example, in this we have two closed islands and all of the other islands are not closed. Okay, this is not closed island and this is also not a closed island. So that is what we need to do in this question. So basically what we will be doing in this question. So now let us try to understand the intuitional algorithm to calculate total number of islands in this given grid. So what we need to do, we just need to identify if the island is touching any of the edges of the grid or not. If it is touching any edges of the grid, which means it is not a closed island. We just need to check if it is surrounded by the water from all sides. Okay, so what we will be going to do in this question, we will iterate all over our grid one by one for each and every element, and whenever we encounter a zero, we will run a depth first search over it. Yes, we will run a depth first search over it, and as we know in this question, we can go on top, left, right, and bottom only. So we can go only in four directions. So we will be trying to go in all of these directions and try to find out our answer. So basically we will move to all of these directions and see if it is a zero, we will move to that island and see if any of the zeros in this island. For example, first of all we encounter this zero, then we will run depth first search all over it, like or breadth first search algorithm, any algorithm, and we will check if any of the zero is at the edges, or is, we can say, is at the zeroth row or the zeroth column, or our last row or last column. If any of the zero is at last row or last column, then this island cannot be our closed island. Okay, so that is what we need to check in this question, and we will achieve that by doing that first search. Now let us just move to, so let us quickly understand the solution by understanding this code. So as we can see in this code, first of all we are getting the rows and columns of the grid, as we need to iterate all over them. So I have taken them global because we will need in this function it in this function as well. So first of all we will iterate over them, and we will not consider the last row and the last column, and the first row and the first column, because even if there is a zero inside them, inside that will not be contribute anything to our answer. Okay, so we will just be iterating through the middle part of our grid. We will not going through last column, last row, first column. We will not be including that. So as soon as we find a grid, element in the grid which is aligned, basically which is which value is zero, is not water, we will call our depth first search, and we will also consider that a boolean value which will be marking false inside our depth first search if it is not enclosed island. Basically if it is touches the boundary of our grids. Okay, so that we will check inside our depth first search. So to run the depth first search, basically we will be going in four direction. Either we will be moving one row next, or one column next, or one row back, or one column uh, one column back. So basically this is top down, bottom and up. We are going by this. Okay, so first of all, whatever we are whatever row and column we are currently at, we will just add these values one by one to it to move to all four directions, and we will also check if it is not going out of the bounds. Basically if it is less than zero, it goes out of the bounds of our grid, or it is greater than the size of our total number of rows and columns, it again goes out of the size bounds of grids. So that is what we are checking here, and then we will check if this is a zero, because we will not consider the one, and we will also consider this grid as an visited array, as we are seeing that we are marking it as one. So we could either use the visited array, because but that will uh, cost us more space complexity. So to reduce that, we are just using this grid in itself as an visited array, you can say that. So whenever we visit a zeroth column, we will say it, and we will mark it as one, so that we do not visit it again. And we will do the DFS again and again, like this, and we will just call for the next row and next column if it is a valid row and column. And as soon as we find any element, any zero, basically any land inside our island is touching the edges of our grid. Basically, it is in last row, basically is it in first row, first column, or last row or last column. We will check that if that is true, this is not a closed island. We will mark this boolean value to false, and we will check this here. If it is boolean value is false, we will not increment our answer. If it is true, we will increment our answer, and this will give us our result. So that is a simple algorithm for this. I hope you got understanding of it. So thank you so much for watching this video. I hope this has helped you. Bye bye.